C1 sequences, exam question Jan 2008, question 7. In this question, we're given a sequence, xn plus 1 is equal to xn multiplied by p plus xn. So this is a recurrence relation because the term that we want is defined in terms of the previous terms. So xn plus 1 is the term that we want, and xn is the term before it. So for part A, it tells us to find x2 in terms of p. So x2 is going to be the one that we want, so it's equal to the term before it. So the term for x2 is x1 multiplied by p plus the term before it, so p plus x1. We know that x1 is 1, so this is going to equal 1 multiplied by p plus 1. So this is just p plus 1. For part B, it asks us to work out what x3 is. Sorry, to show that x3 is equal to 1 plus 3p plus 2p squared. So x3 is the term that we want. This is equal to the term before. It's the term before x3 is x2 multiplied by p plus x2. We've just worked out that x2 in terms of p is p plus 1. So we can put that into here. So we've got p plus 1 multiplied by p, and then x2 is p plus 1, so plus p plus 1. So we've got p plus 1, and then we've got p plus p, which is 2p plus 1. Now I can expand this, so I've got p squared, p multiplied by 2p, so I get 2p squared, p multiplied by 1, which is p, 1 multiplied by 2p, which is 2p, and then 1 multiplied by 1, which is 1. And then I can collect like terms, so I've got p plus 2p, which is 3p, and then plus the 1. So I've got x3 is equal to 2p squared plus 3p plus 1, which is what I was required to get. The next bit tells us that we are given that x3 is equal to 1 and we need to find the value of p. So if we look back, p is a constant, but p does not equal 0. So we've been told that x3 is 1. So instead of x3 we can put 1 into there. So we've got 1 is equal to 2p squared plus 3p plus 1. So that's a quadratic that we need to solve in order to find p. So before I can do that, I'm going to bring this 1 over to the other side. So I'm left with 0 on this side. So I get 2p squared plus 3p. So I've got 1. I'm taking away 1, so I get 0. So now we need to factorise this to find p. If I look at this, I've got p, which is common in both of these, so I can take that out. So I'm left with 2p plus 3. So either the bit outside the bracket is equal to 0, or the bit inside the bracket is equal to 0. So either p is equal to 0, or 2p plus 3 is equal to 0, in which case p is equal to minus 3 over 2. But because we've been told in the question at the top that p does not equal 0, we know it can't be this one. So we know that p is equal to minus 3 over 2. Last bit, part D, so this was part C. Part D asks us to write down the value of x 2008, the 2008 term. So if we look at this, our first term x1, we were given it to be 1. Our second term x2 is going to be p plus 1. So now we know that p is minus 3 over 2. We know that our second term is going to be minus 3 over 2 plus 1. x3 is going to be 2p squared plus 3p plus 1. So if I put minus 3 over 2 into there, I end up getting 1. So the terms of my sequence are, the first term's 1, the second term I've got minus 3 over 2, add 1, which gives me minus a half, and my third term is 1. So if I keep working out the next few terms, I can see that I keep getting 1, minus a half, 1, minus a half, 1, etc. So if I look at this, that's my first term, that's my third term, and that's my fifth term. All the odd terms are equal to 1, and all my even terms are equal to minus a half. So when I'm working the 2008 term, that's an even term. So that's going to equal minus the half.